Remember, relative frequency is also known as experimental probability. Those two words are synonyms, and it's based on the actual results of an experiment. In other words, what actually happened. The theoretical probability comes from the calculated results and the knowledge of the possible outcomes. So this is what should happen. Experimental probability and theoretical probability may be close, but are rarely exactly the same. So to find your experimental probability, you need to divide the number of times an event occurs by the total number of times that the experiment is carried out. And keep in mind that this value will change every time you conduct that experiment. So if you flip a coin 10 times, then the total number of times the experiment is carried out is 10. If you flipped a coin 25 times, then the bottom number of your ratio changes to 25. And every time you carry out that experience, you change the total number of times for that experiment. And the number of times the event occurs will also change as well. Remember, experimental probability tends to get closer to that theoretical probability of an experiment the more times you conduct those trials. So flipping a coin 10 times may not get you 5 heads and 5 tails, but flipping a coin 1,000 times will probably get you very close to 500 heads and 500 tails. Now let's answer some questions together. In numbers 4 through 6, complete each statement. Kelly flips a coin 20 times. The results are shown in the table, where H represents the coin landing heads up and T represents the coin landing tails up. So you can see in the table the result of flipping a coin 20 times, and each result of the flip is recorded. So when Kelly flips the coin 20 times, she is looking for the number of times she gets heads and the number of times she gets tails. So count those up. And then we're going to make fractions out of the two of those using the denominator of 20, because that's how many experiments were conducted. For this experiment, Kelly flipped heads 11 times and flipped tails 9 times out of the 20 total flips. Now look at question 4. The theoretical probability that the coin will land heads up is the number of possible outcomes and the number of favorable outcomes. In other words, heads, which is still 1/2 or 50%. Remember, this tells us what should happen when we flip a coin. Half the time it's heads, half the time it's tails. Number 5 says, based on the data, that means from the table, the experimental probability that the coin will land heads up is 11 out of 20. And what percent is that? That would be 55%. So how does the theoretical probability compare to the experimental probability? In this problem, the experimental probability is greater than the theoretical probability. Remember, experimental was 55% and theoretical was 50%. Now let's try some more practice problems. Let's look on the practice and problem solving page at questions 7, 8, and 10. Number 7, the table shows the results of spinning a wheel 80 times. What is the relative frequency of the event spinning a 3? So on the wheel spins, we're looking for the outcome of spinning a 3. How many times did that occur? And it occurred 18 times. So the number of times that the event occurred is 18. What is the total number of trials? Well, remember that the frequency was how many times did they spin the wheel? And they told us that up in the problem that they did it 80 times. Now we can simplify that fraction. And we can change that into a percent. So 22 5/10% is the relative frequency for the wheel landing on 3. Number 8, Liz flips a coin 50 times. The coin lands heads up 20 times and tails up 30 times. Complete each statement. The theoretical probability of the coin landing heads up is 1/2 or 50%. Remember, theoretical is what should happen. But based on Liz's results, the experimental probability of the coin landing heads up is 20 out of 50, which is actually only 40%. So this time, the theoretical probability is greater than the experimental probability for this experiment. Number 10. The table shows the results of a survey of 100 people randomly selected at an airport. Find the experimental probability that a person is going to city E. Well, remember they asked 100 people, so that's our total. And how many people said they were going to city E? That would be 8. So the relative frequency, or the experimental probability of a person going to city E would be, anybody know? That's right, 2 out of 25, or 8%. And last but not least, let's try questions 13, 14, and 15. Question 13. Each of 3 friends flips a coin 36 times. Angel records tails 20 times, Michael records tails 17 times, and Fernanda records tails 23 times. So Angel has a relative frequency of 20 out of 36. Michael has a relative frequency of 17 out of 36. And Fernanda has a relative frequency of 23 out of 36. B. Which friend has a relative frequency that is closest to the theoretical probability of flipping tails 36 times? Explain. Well, the theoretical probability that I'm going to flip tails is 1/2. In this case, how many out of 36 would that be? So remember, solve this like a proportion. And 36 divided by 2 is 18. So which friend was closest to that theoretical probability? And that would be Michael. He was only off by 1, whereas Angel was off by 2, and Fernanda was off by 5. Number 14. In a survey, 125 people were asked to choose one card out of 5 cards. Choose one card out of 5 cards labeled 1 to 5. The results are shown in the table. Compare theoretical probability and experimental probability of choosing a card with the number 1. Well, let's first take a look at your theoretical probability. In other words, what should happen. In this case, because there are 5 cards, each numbered from 1 to 5, you have a 1 out of 5 chance of drawing a card with the number 1. So your theoretical probability tells us there is one favorable outcome, and that's drawing the card with a 1 on it, out of 5 possible outcomes, which are the 5 cards that you have to choose from. However, the experimental probability, remember, is different. It's based on the information that you are given in the table. In other words, the frequency, or the number of times that the card with the number 1 was chosen, is 15, and that's out of 125 people that were asked to choose a card. In order to accurately compare these two probabilities, it might be best to change them into decimals or percents. So let's change them each into percents, and then we can make an accurate comparison. In this case, the theoretical probability of choosing a card with the number 1 is 20%, but the experimental probability from actually conducting that experiment and choosing cards by 125 people found that the experimental probability is only 12%. So the theoretical probability is greater than the experimental probability. Number 15. The best player on basketball team makes 75% of all free throws. The second best player makes 70%, and the third best player makes 65%. Based on their experimental probabilities, estimate the number of free throws each player will make on his or her next 40 attempts. So in other words, when we see these probabilities listed as percentages, and I'm going to label these players number 1, number 2, and number 3, we can use that percentage and change it into a ratio out of 100. So player number 1, 75% means 75 out of 100. Player number 2 would be 70 out of 100, and player number 3 would be 65 out of 100. Now we could easily simplify these ratios in order to set up a proportion for the next 40 attempts, or we can just use the ratios that we have. In other words, I want to know how many would player 1 make out of 40, how many would this be for player 2 out of 40, and how many for player 3 out of 40. So in other words, to solve each of these proportions, I would need to take 40 and multiply both sides of the proportion by that number. So in the case of player number 1, we have 40 times 75 divided by 100. In the case of player number 2, we have 40 times 70 divided by 100. In the case of player 3, we have 40 times 65 divided by 100. So let's figure out how many free throws that would be for player 1, player 2, and player 3. In this case, player 1 would be expected to make 30 out of the 40 free throws. Player number 2 would be expected to make 28 out of the next 40 free throws, and player number 3 would be expected to make 26 out of the next 40 free throws. Now you're ready to try some problems on your own.